So, guys, let's start going today. Today we're talking about law of sines. So, solving a triangle that is not a right triangle using law of sines. So, there is a law of sines, there's a law of cosines. Law of sines is the easier of the two. Alright, so what we're going to talk about today. Now, everything we've done so far in trig has been using right triangles. Right? All 6 trig functions we've learned, you had to have a right triangle to do. Now, with law of sines and law of cosines, we can do that without a right triangle. Right, with any type of triangle, we can use law of sines and law of cosines. So, the law of sines, it's just one big ratio. Right, so what happens is sine of angle A over side A equal to sine of angle B over side B equal to sine of angle C over side C. It's one big ratio. You can flip them over as long as you have both side lengths on top and then angles on bottom, or vice versa. Now, the big key here is knowing that side A is straight across from angle A. And side B is straight across from angle B. And side C is straight across from angle C. Alright, so straight across from each of those angles is its complementary side. So when I'm doing it, sine of A over A, sine of B over B. Now, you do not need to list all 3 of those out to start solving. Right? A lot of times we'll just use 2 of them. So we'll use like sine of angle A over side A equals sine of angle B over B. That's fine, because they all equal each other. We don't need to use all 3 at once. So if we're trying to do like a problem, we're asked to solve a triangle. We have a triangle ABC. I'm given angle A. I'm given angle B. I'm given side A, right? It's straight across from angle A. Normally we'd say we can't solve this triangle. Hold on. What does it mean to solve a triangle, by the way?
All sides and all angles.
All sides and all angles. So normally we'd say we can't do it because we don't know enough information. But now we do. What we're going to do, sine of angle A. So sine of 30 over side A, which is 10, equals, we're going to solve for side B, because I know angle B right now. Sine of 45 over B. Right, set up that ratio, set up that law of sines. Well, how do you think we can solve that? What was that, Jalen? Cross multiply. Right, cross multiply this. 10 times sine of 45 equals B times sine of 30. And then how can I solve for B? Divide by sine of 30. So B equals 10 times sine of 45 over sine of 30. Well, what do you get when you put that in a calculator? That is in degree mode.
14.14.
Everybody else got? So B approximately 14.14. Sweet, we found one side. How do you think we're going to find our other side? Well, we need to have at least 3 pieces of information. Fuji?
We can start by finding angle C using the triangle that goes 180 degrees.
Perfect. We can start by finding angle C. We know every triangle adds up to 180 degrees. So if I have 2 of the other angles, I should be able to find my third angle. So 180 minus 30 minus 45 should give me angle C, which should be 105 degrees. So angle C is 105 degrees. Alright, so now I have angle C. I'm still going to use angle A and side A. Why do you think I chose that instead of using angle B and side B, Violet?
Because angle B and side B are the side would be rounded.
The side's already been rounded, right? Now, you can use it. You might be a little bit off compared to what my answer is. I would try and stick to the ones that were given. Right? Anything that hasn't been rounded yet, it's usually a better idea to use because you get a more accurate estimation. Right? So let's set that one up. I'm going to do it over here. I'll erase it. So sine of angle A, sine of 30, over side A, which is 10, equals sine of 105 over side C. Right? We're looking for side C. So, cross multiply and solve it. 10 times sine of 105 equals C times sine of 30. And same thing, divide by sine of 30 to get C by itself. What do we get for C?
19.32.
C is approximately 19.32. Okay? Everybody get that? Yes, no? Maybe, I guess. I don't know. Alright, I want you guys to try the next one. Try the next one. It's a little bit different. Might be a little bit trickier. If you have problems, let me know. Ask for help. Yes, sir.
For like, so would this be A then?
That would be sine.
This is pointing towards it?
Yep.
Right, and this is C and
Is
this
it always
Yep.
sine?
Good. So remember, guys, the side A is across from angle A.
Because that,
We all look confused. Why are we all looking confused? You need an angle. Well, here, let's find. Here, we'll find you an angle. All right. Okay. I have angle A and I have side A, right? So I'm going to use those two. Sine of 37 over 15 equals. What is the only other angle that I can find at this point? C, right? I have this side for C. I just don't have the angle. So instead of putting sine of angle over C, it's going to be sine of C over the side over 11. So cross multiply once again. Sine of 37 times 11 equals 15 times the sine of C. Well, divide by 15, right? Let's start with that. Divide by 15. So I get sine of 37 times 11 divided by 15 equals sine of C. What's my last step I got to do here? Right? I want C. I don't want the sine of C. You got to do the inverse, because we got to get that C by itself. Right? So let's do the inverse of both sides. So inverse. Inverse. So C equals the inverse sine of sine of 37 times 11 divided by 15. So if I was in my calculator, this is just how I would do it. Sine of 37 equals, right, then we have what? Times 11. Times 11. Divided by 15. And then I would do second sine, do the inverse sine, and pull that answer, so second answer. So when I hit enter, I should get my angle, which is going to be what? 26 degrees, right? We're talking about angles, we're going to the nearest whole degree. So 26 degrees. So angle C is 26 degrees. Can you do it from there? Alright, 26 degrees. Alright, find angle B now, and then find side B.
Simplify your stuff. So you cross out.
Find angle B, and then find side B. 15 x 9. That's straight across. No, I'm looking for B. So that means we're looking at the side.
So should you use the inverse sign?
This is 117.
Or 117
You divide it by sine 2 sides, right?
Yeah.
Both sides.
You're supposed to say inverse, or you're supposed to say one?
No, I would just divide it.
Divide it.
Right, the only time we use inverse is when you can play an angle, and it's like sine of a variable.
Okay.
It's just like, it'd be like 3 times x, we do division, which is the inverse multiplication. Inverse of sine. Yep.
Is it possible to look
That one? Sure.
No, not this one. The other one.
No.
This is 2 days.
Alright, so angle B we got to be what? Noah, what'd you get?
117 degrees.
117 degrees. Okay. So an angle, or side B, excuse me. I know I'm going to have to use angle B, so sine of 117 over B equals. And you can pick either angle A inside A or angle C inside C. So let's just do sine of 37 over 15. And you'd cross multiply and you'd solve for B. And what would we get? Q, what'd you get?
22.
22?
Wait. I was talking about the answer.
Did it come out to that nice of an answer?
Oh, we have to go.
Oh,
100. My
side
bad.
lengths are hundredths place.
22.
Angles. 22 point what?
22.21.
21. Okay. Let's see, I didn't think it was that nice of an answer, but. Alright. Guys, any questions? Alright, we have 2 application problems. Do one? Do one? The second one's kind of really easy. I wouldn't say really easy, but we'll do the first one. I like the first one because we gotta do 2 parts to it. So I'm gonna redraw the picture because that picture kind of sucks. So we have Station Baker. I'm gonna call it Station B. And I have Station Able. Call it Station A. And so I have those 2 stations along a shore. There's a ship. Draw my ship. There's a ship out at sea. Call it SOS. Station Able indicates the ship is located 35 degrees north of east. So north of east. So if I'm going east, I'm going to the right. And it's north of that. That means this is 35 degrees. Okay? It's even on our picture. The call of Station Baker indicates the ship is located 30 degrees south of east. So I'm going east again. South of that, 30 degrees. So I'm going to connect the 2. They are 150 miles apart. Do these angles out here help me? Yeah, what do they help me find? The angles inside, right? Because this has to add to 90. So what I would do first is I'd find those 2 angles inside the triangle. We're going to get 60. Going to get 55. Alright, we want to know how far is each station from the ship. So I need to find how far Able is from the ship and how far Baker is from the ship. Okay? So this is going to be, ooh, I don't know how to want to look at that. So this is A, this will be side A, this is B, this will be side B. I need to find both of those. Well, before I can do that, I need to have a pair. I need to have an angle and a side, right, that I can put into my law of sines. So I need to find my third angle as well. 180 minus 60 minus 55. What do I get? for that third angle in this triangle?
65.
What?
65.
65? Okay, so 65. So now I have an angle and a side that match. That's huge. I need to have that. I need to have at least one angle and side that match. So I'm going to do sine of 65 over 100 equals. I'm going to solve for Baker to the ship first. I'm going to solve for side A. So sine of 55 over A. Does everyone follow me so far? Ethan.
Where'd you get the 100?
Great question. 150, thank you. Thank you. Alright, so sine of 65 over 150 equals sine of 55 over A, cross multiply. A times sine of 65 equals 150 times sine of 55. Well, divide by sine of 65 on both sides. What do we get? A is approximately what?
90.38.
That everybody else got?
Let me check it.
I got 135.5.
135.58? That sounds better to me.
135. Why do I 150?
Why are you dividing by 150?
No, that's not what I did. This is what
You just said that.
I multiplied it by sine 55 times 100, and I got 81.9.
Oh, because I accidentally had 100 on the board earlier. It's supposed to be 150.
Oh,
That's my fault. I messed Patrick up. It's fine. Alright, hey, so from Station Baker, that's saying it, that's alright. Station Baker to the ship is 135.58 miles. Now I need to figure out how far it is from Station Able to the ship. So I'm going to do the same sort of thing, right? Still using law of sines. I figure it out. So sine of 65 degrees over 150 equals, now I'm using angle 60 to find B. Sine of 60 over B. Same sort of thing. Cross multiply and then solve them. B times sine of 65 equals 150 times sine of 60, and then divide by sine of 65. What do we get B to be approximately?
143.35.
143.33 miles. Station Able. So realistically, which of our two stations is closer to the ship? Station Baker, right? It's about 8 miles closer approximately to Station Able. Okay? Does that make sense? Do we have any questions? Do you want the homework? Alright. If you want to see